In this video, we're going to talk about confidence intervals for population variance. And building confidence intervals for population variance is slightly different than building confidence intervals for population proportion or population mean, in that we're not going to focus around a point estimate. Okay, again, and also there is no central limit theorem for sample variance, but we could still manage estimating the population standard deviation or population variance based on the fact that this ratio of the sample variance divided by population variance and the denominator is magnified by n-1 degree of freedom, follows a well-known distribution, which is called a chi-square distribution. Now, this distribution is not a normal distribution. If you remember, when we were covering it before, it's a distribution that's skewed to the right, and it starts with a 0 and goes into the infinity. So the critical values on the left side and on the right side of the chi-square distributions are not symmetrical, unlike the z or t distribution. Remember, with the z or t distribution, we had center of 0 in the middle of the distribution. Here, it starts with a 0. And it's not symmetrical. So we're gonna, for our critical values, our critical value chi-square on the left and chi-square on the right are gonna be not gonna be symmetrical. They're both gonna be positive values and they're not gonna be equal. So you would have to find them separately using the chi-square distribution. Okay, now the requirements are as follows. We need a simple random sample. And requirement number 2, the population must be normally distributed. Remember, with estimating population mean or population proportion, we could compensate. If the population was not normally distributed, we could have a large sample to compensate for that. With estimating population variance, we don't have that. We must have a normal distribution, no matter what the sample size is. And if we do that, if we have all of these requirements met, then we could calculate or estimate our population variance based on this formula. So this would be your left bound or lower bound for the interval, and this will be your upper bound for the interval. One more thing that I wanted to mention here is that if we are asked to estimate population standard deviation instead of variance, we would have to square root all parts of this inequality. Together, let's take a look at this problem. It says, for a certain drug, based on standards set by the United States Pharmacopoeia, an official public standard setting authority for all prescription and over-the-counter medicines and other healthcare products manufactured or sold in the United States, a standard deviation of capsule weights of less than 2 milligrams is acceptable. A sample of 10 capsules was taken and the weights are provided below. Construct and interpret a 90% confidence interval for the standard deviation of the weights of all capsules. You may assume that the weights of capsules are normally distributed. So let's check our requirements first. We need a simple random sample. which we have. Says a sample of 10. Well, we will assume it was a random sample, even though they did not specify it, but we'll just, for the purpose of this demonstration, we'll assume that it was a random sample with n that equals 10. That's important. We need a degree of freedom. Okay, what else do we know? Well, we know that the confidence interval is a 90-degree confidence. Oh, well, let's keep on checking our requirements. It says the weights of capsules are normally distributed. So both of our requirements are checked. Now let's continue. What else do we know? 90% confidence interval. So alpha is 1 minus 0.9. That gives us 0.1. Okay, now I put my values into StuckCrunch and I found the mean and the standard deviation of the sample. So the mean of the sample is 100.15, and the standard deviation of the sample is 1.1890. Now, in my formula, I'm going to have S squared, which is variance. So I may as well calculate the variance and copy it down right now. All right. What I also need, I need my chi-square values. So I'm going to go to Stat Calculators and select chi-square. Here's my chi-square distribution. I'm going to put 9 for the degree of freedom. And I will need to find two values. Remember, my alpha is 0.1. Alpha divided by 2 will be 0.05. So that's what I'm going to put into this field on the right, 0.05. And I'm going to compute this chi-square that separates the bottom alpha over 2 region. And that chi-square value is 3.325. I'm going to round to 3 decimal places. Okay, now I need to find another one on that side. So I'm going to switch the sign here, but also need to switch the area. And that chi-square value on the right now is 16.919. All right, now I have everything I need to estimate my variance. I want to remind you what the formula looks like, and here it is. And but in the formal formula, we have alpha over 2 here, and we have 1 minus alpha over 2 here. I just used the left and right subscript to indicate that on this side, we're going to put the value on the right-hand side. So in the left side of the formula goes the value from the right side of the chi-square distribution. And into the right side of the formula, we're getting the value from the left side of the distribution. Okay, so just keep that in mind. Let's fill in the information. And remember, I told you I'm going to have the S squared in the formula, so I copied that value. So I'm going to copy it here. multiplied by the degree of freedom, and divided by chi-square from the right. So that would be 16.919. And same on this side. So the top is exactly the same. But the denominator is going to be the chi-square value from the left side. So 3.325. And that makes sense too, because the value on the right is greater than the value on the left. And when you put it into the denominator, the greater value in the denominator makes the entire fraction smaller. So this value is smaller than that value. And that makes sense in terms, if you think in terms of intervals. So when I put this into my calculator, I got 0.752113 for this fraction. And then for this fraction, I got 3.827068. All right, so, but notice we got the interval for population variance. But they asked us for the population standard deviation, I believe. Yes. So according to this regulatory institution, a standard deviation of capsule weights of less than 2 milligrams is acceptable. So we still have to figure out the standard deviation. And in order to do that, we're going to square root all parts. So we need to square root sigma squared, and we're going to square root all parts of this inequality, which gives us 0.867 on this side, and 1.95629 on the right side. Okay, so the interval, I'm gonna so this is one way to write the interval. Another way, and I'm gonna round to 3 decimals, would be 0.867 to 1.956. So that would be another way of writing that interval. Okay, now let's go back to the question. Are our standards, are we within the standards? And the answer is yes, because our entire interval is below 2. Now, this is important. If 2 was included in this interval, even if it just touched it, let's say that instead of this right bound, instead of 1.956, we got 2 or 2.0001. Since 2 is still included in this interval, it is possible that the actual standard deviation is 2. Okay, it's a possibility. So anything in the interval is a possibility for the true standard deviation. So, and in this case, we would say that we're not within these standards. We would have to do more investigation, maybe take a larger sample size to get more accuracy on our estimation, or do something else. But we could not say that our standard deviation is below 2 milligrams. But since the entire estimated interval is below 2, then we could say that yes, it's definitely, we're within the regulations for now. So what do we conclude? We're going to say that we are 90% confident. Remember our confidence intervals? We have to include it in the conclusion. That the population standard deviation is between 0.867 and 1.956 milligrams. And why are we worried about it? Well, because therefore the capsule weights deviate less than 2 milligrams and are in accordance with the standards. Okay, again, I just want to reiterate it again. We can conclude that it's less than 2 milligrams is because the entire confidence interval is below that value. It's not included in the confidence interval. That's important. So here's a bird's eye view of the material that we covered so far. So this is a summary of what we learned. So when we're estimating a population parameter, first we have to identify which parameter we're estimating. Is this a population mean? Is this a population standard deviation? Or is this a population proportion? Remember, proportion could also be a probability or percentage. So once we identified that, then you select a formula and the distribution that you need in order to estimate your confidence interval and get your critical values. So if you know that you're estimating population mean, we have two situations. The one is that the standard deviation is known. In this case, you would use the standard normal or Z distribution for critical values. However, as I mentioned before, this is not a very realistic situation, so we're not going to go in depth on this one. Now, the more realistic situation is when you don't know your standard deviations, your standard deviation of the population. In this case, you will use a T distribution to figure out your critical values. That's for estimating population mean. For estimating population proportion, you're going to use the standard normal distribution, Z, for calculating critical values. And if you're talking about confidence intervals for population variance or standard deviation, then you're going to use a chi-square distribution to find critical values. Now, once you identified what you're estimating and which distribution to use for critical values, then you will apply a corresponding formula, right? So these are the formulas for your confidence intervals, estimating confidence intervals. So T critical value for estimating population mean standard deviation is unknown. Z for estimating population proportion, and chi-square for estimating variance or standard deviation. In this section, we also talked about estimating population, sample size necessary to estimate a population parameter. We have two formulas, one for estimation of the population mean and another one for estimation of population proportion. In both cases, you will use the standard normal distribution or Z distribution in order to find those critical values.